Hi, my name is KANG, and today I'll be presenting my final year project titled RDC means Long Short-Term Memory with Application in Exchange Traded Funds. These are the contents I'll be going through today. I'll start with an introduction. These are the concepts used in the project. Neural networks are a powerful tool that mimics the function and structure of a human brain. A trained neural network is able to have a high accuracy in mapping a set of inputs to outputs. However, neural networks are commonly criticized as a black box. Neural networks create complex mathematical functions within itself and hence has low interpretability for humans to directly interpret how it maps the inputs to outputs. Fuzzy systems resembles the human reasoning and provides interpretability by introducing the concept of linguistic values and rules. However, the system itself generally requires a domain expert to generate a set of rules. By integrating the two concepts to achieve accuracy in results and interpretability, fuzzy neural networks were created. An example of a fuzzy neural network is the modified Jaeger fuzzy neural network created by SIEK. It is a 7-layer architecture and can receive multiple inputs and will generate a single output. I will now talk about the proposed FCMLSTM. These are the features of FCMLSTM. The rule base is generated based on data using the FCM clustering algorithm. Each cluster will represent a rule inside the rule base. Given a sequence of inputs, FCMLSTM can predict the output value of the next sequence. FCMLSTM is able to achieve the accuracy of neural networks and interpretability of fuzzy systems. FCMLSTM follows the Mamdani inference process consisting of 5 steps: fuzzification, apply fuzzy operator, apply implication method, apply aggregation method, and defuzzification. This is the architecture of FCMLSTM. It is a 5-layer architecture. In the input layer, crisp input is fed into FCMLSTM. In the antecedent layer, fuzzification by FCM is applied to convert crisp input to fuzzy input. In the inference rule-based layer, based on the fuzzy input, LSTM will generate a fuzzy output. In the consequent layer, the fuzzy output remains unchanged as the output by LSTM represents an implicated and aggregated output. In the output layer, center of gravity defuzzification method is applied to convert fuzzy output to crisp output. I will now go through the experiment conducted using FCMLSTM. FCMLSTM process consists of 4 steps. Step 1 is to apply STM to the dataset. Step 2 is to train the LSTM using a training dataset. Step 3 is to predict the next sequence fuzzy output. Step 4 is to apply defuzzification to convert the fuzzy output to crisp output. These are the results experimented on 3 ETFs. FCMLSTM is used to predict the closing price of each ETF up to 12 days ahead. The R-square values are all above 0.9. This indicates that the predicted value follows the trend of the actual value. The graph shows the predicted value against the actual value for predictions of t plus 12. It can be seen from the graph that the predicted value follows closely to the trend of the actual value. I'll now talk about our portfolio rebalancing strategy. The portfolio of ETFs used contains these 6 ETFs. The trading strategy used in our portfolio rebalancing will be moving average convergence divergence. MACD is a trend indicator used in stock trading analysis. MACD is calculated by subtracting the 26-day slow exponential moving average from the 12-day fast exponential moving average. The signal is calculated by finding the 9-day exponential moving average of MACD. Using MACD and signal, the crossover will generate a buy or sell signal. However, the problem with MACD is a lagging indicator calculated with past data. MACD is also prone to frequent crossover signals where generating frequent trades results in more trade commissions and affects profits. The solution would be to use the predicted MACD with genetic algorithms. The lag can be reduced by using predicted FCMLSTM values in MACD calculations. The MACD parameters can also be optimized through genetic algorithms to improve results. Genetic algorithm is a search heuristic where the fittest individual in the population based on the fitness value is selected to breed with a probability of mutation. The individual with the highest fitness value represents the optimal parameters to be used. The parameters undergo genetic algorithms will be fast, slow, signal, as well as the crossover threshold. The results will be the optimal parameters to be used for MACD calculations. These are the results from our portfolio rebalancing using the predicted MACD trading strategy. We evaluated the results using return of interest and annualized return of interest over the period of 8 years. Predicted MACD-GA was able to generate the best returns compared to buy and hold and normal MACD. Lastly, we have reached a conclusion. FCMLSTM integrates accuracy of neural networks and interpretability of fuzzy systems. From the experiment, we are able to obtain high R-square values above 0.9, which shows that it is able to predict the trend. Using FCMLSTM and genetic algorithms, we came up with the predicted MACD-GA trading strategy which outperforms buy and hold and normal MACD. Future works regarding FCM-LSTM will be to look into variations of FCM such as density-oriented FCM and LSTM parameters optimization to obtain higher R-square values. For portfolio rebalancing, we can consider the number of assets used in our portfolio as well as testing during volatile market conditions where MACD may benefit from the wild swings in prices. I have now come to the end of my presentation. Thank you.